Now we will discuss about the types of fluid. Types of fluid. This is same page. So there are basically two types of fluid. One is Newtonian. Newtonian. The other one is non-Newtonian. Non-Newtonian. And this non-Newtonian fluid is further divided into two subcategories. The first one is time independent, and the second one is time dependent. The time independent are further classified as dilatant or shear thickening, Bingham plastic, and pseudoplastic. Pseudoplastic, which is shear thinning. And the time dependent are classified as Thixotropic, and Rheopectic. Rheopectic. So these non-Newtonian fluids, they do not follow the Newton's law of viscosity, which was, as we discussed in the previous video, it was tau equals to mu du dy. For non-Newtonian fluid, the relationship for non-Newtonian fluids, relationship between shear stress and velocity gradient is tau equals to a du dy to the power n plus b, where a and b are the constants depending on type of fluid and condition of flow. For example, for dilatant fluids, for dilatant, n is greater than 1, b equals to 0. These dilatant fluids are like butter, quicksand, and for Bingham plastic, n equals to 1, b not equals to 0. Example, sewage sludge, toothpaste, gel. These fluids always have certain minimum shear stress before they yield. Alright? Then it comes pseudoplastics. Here n is less than 1 and b again equals to 0. Pseudoplastics are like paper pulp, lipstick, paints, paints, paper, pulp, lipstick, blood, etc. And then Thixotropic. So Thixotropic, here n is less than 1, b not equals to 0. In this thixotropic, the viscosity increases with time because this is a time dependent. Viscosity increases with time. The examples are like enamels, printer ink, where basically the base evaporates and it becomes more denser. And the last one is Rheopectic. Here n is greater than 1 and v not equals to 0 as well. Here viscosity, unlike thixotropic, here viscosity decreases with time. For example, bentonite solution, bentonite solution.